All right, here we go. Lesson 17, modeling with inequalities. Let's look at solutions to inequalities. I can use the I can statement. I can use what I know about inequalities to solve real-world problems. All right, 17.1. The stage manager of the school musical is trying to figure out how many sandwiches he can order with the $83 he collected from the cast and crew. Sandwiches cost $5.99 each, so he lets X represent the number of sandwiches he will order and writes $5.99 times X is less than or equal to 83. He solves this to two decimal places, getting X is less than or equal to 13.86 sandwiches. So number one, which of these valid statements are true? Which of these are valid statements about the situation? He calls the sandwich shop and orders exactly 13.86 sandwiches. Probably if you call a sandwich shop and order 13.86 sandwiches, they're going to laugh at you. So that one, he can round up and order 14 sandwiches. Well, if we go 14 sandwiches, let's go 14 sandwiches times $5.99. It's $83.86. So he cannot round up. So that one's out. He can order 12 sandwiches. Yeah, he can order 12, and he can order 9.5. Sure, the sandwich shop might make a half a sandwich. He can order 2 sandwiches. Yep. He can order -4 sandwiches. Nope, not possible. There's no such thing as -4 sandwiches. All right. 17.2, elevator. The mover is loading an elevator with many identical 48-pound boxes. The mover weighs 185 pounds. The elevator can carry at most 2,000 pounds. Write an inequality that says the mover will not overload the elevator on the particular ride. Check your inequality with your partner. So we know he's moving 48-pound boxes, but we don't know how many. So we can go 48 times X plus the 185 pounds that he weighs at most, okay? At most it can be, but it's got to be less than or equal to. And at most would be 2,000 pounds. Oh. Okay, so there's my inequality. All right. Now solve your inequality. All right, so we're solving it just like we solve an equation. Here's my X. Here's my sign. The first number we get rid of is the number not with X. So we're going to subtract 185. Okay, so we have 48X is less than or equal to 1,815, I think. Let's see. 2,000 minus 185 is 1,815. Okay, the 48X means 48 times X, so to get rid of times, we divide. So 1815 divided by 48-pound boxes is 37. So X is going to be less than 37.815 boxes. Once again, we can't have 0.815 of a box. So we're just going to round down because it can't be greater because we don't want the elevator to collapse. So we're going to round down to 37 boxes. Graph the solution on a number line, okay? So graphing, we can put 37 wherever we want. Okay, here's the thing with graphing we haven't talked about yet. But if it's less than or greater than, it's going to be an open circle. If it's less than or equal to or greater than or equal to, so now there's a line underneath it, it's going to be a closed-in circle. So there's no line underneath it here. Here's my inequality. X is less than, so we're going to put an open circle at 37. And we're going to go to the left. So it can be smaller than. If you notice the sign here, a less than sign points to the left. If I draw an arrow and point it to the left, that makes it work. All right. 17.3 we're going to skip, and that's it. So the summary, we can represent and solve many real-world problems with inequalities. Whenever we want to write an inequality, it's important to decide what quantity we are representing with the variable. After we make that decision, we can connect the quantities in the situation to an expression and finally the whole inequality. As we are solving the inequality or equation to answer the question, it's important to keep the meaning of each quantity in mind. This helps us decide if the final answer makes sense in the context of the situation. For example, Han has 50 centimeters of wire and wants to make a square picture frame with the loops to hang it. For example, Han has 50 centimeters of wire and wants to make a square picture frame with a loop to hang, so it uses 3 centimeters for the loop. This situation would be 3 plus 4s equals 50, where s is the length of each side if we want to use all the wire. We can also use 3 plus 4s is less than or equal to 50 if we want to allow for solutions that don't use all the wire. In this case, any positive number that is less than or equal to 11.75 is a solution. Each solution represents a possible side length for the picture frame since Han can bend the wire at any point. In other situations, the variable may represent a quantity that increases by whole numbers, such as numbers of magazines, loads of laundry, or student. In those cases, only whole numbers of solutions make sense. All right, there you have it. Remember, if you have any questions, you can always send me an email.